of IEM, all the distinguished guests here, uh, all the educators, and I'm sure the team from US Embassy is here, the team of the Rajiv Gandhi Science Center, and all space fashion lovers and who are here for this event. Welcome all of you. And today is like Mr. Rangu mentioned, we are the event in the context of Freedom 2050. Okay, and I think it's an opportunity to look back into the achievements in the past, but also mainly to ponder into the window of the future. I think this is there. And how Rajiv Gandhi in Mauritius, but is mandated to promote popularized science and with this an icon in the region. In fact, a month ago, we had the visit of Mark Burrell, who is engagement specialist for East Africa on the American Maker Spaces. He was here and he had a very good session with our students and staff. And what his observation was, he rated the AMS in Mauritius as one of the to lay back to or to become professional in the STEM. The AMS provides a foundation for youth to think out of the box, a platform for them to bring their ideas, bring their creativity and innovativeness so that they can make their ideas become reality. And we provide all the support and tools thanks to the support of the US Embassy. And last year, we renewed our MOU with the US Embassy and on the American Makerspace. And we were very opportune to have what we call Captain Cockrell, Kenneth Cockrell, the next astronaut. Again, such opportunities of NASA. What comes to your mind? I think many words come to your mind. It's a dream, it's a passion. Well, for me, it's inspired thoughts about space exploration, breaking scientific and technological barriers, thinking the unimaginable, the incredible things, how to go into space. Lots of things, but it's beyond human capabilities that we think is incredible. And this is what NASA is doing. And today we are very opportune and privileged to welcome Mr. Jim Adams. All the aspects I've been mentioning, I think it's in one package in front of me, Mr. Jim Adams. So on behalf of the Rajiv Gandhi Science Center person, I welcome you. I think he deserves a big round of applause. Welcome, Jim. What I can tell you, his career spans over the number of times he's been to Africa. And so grateful that first time he's been able to go beyond Africa to Mauritius. So we'll have to hear from him. We'll have to hear what he has to say. And also, we have a special photographic session prepared by the US Embassy, and we look forward to that. Of Abdul Kalam. He mentioned that
Mr. Jim and is an excellent trust from both actors, educators, members of the media, distinguished. My great pleasure on behalf of space exploration, it is discovery, innovation, and international collaboration. The Freedom 2050 program organized by the U.S. Embassy highlights emerging technologies, innovation, this vision by exposing participants to global NASA Deputy Chief Technologist who provide an exception promotion students, educators, researchers, and professionals to learn from one of the leading voices in the field of space innovation. Similarly, ladies and gentlemen, space exploration has always represented humanity at its best. Collaboration across research and STEM capacity building are essential for building resilient and sustainable societies. It is our hope that programs such as strengthen partnership to the US Embassy for its continued collaboration, support our initiatives in Molucca. Has been sharing his insights on space and students room for your encouraging words and for your continued commitment. Ladies and gentlemen, the collaboration between the Russian government is the value of international cooperation in advancing scientific knowledge and strengthening cultural ties. Over the years, several landmark activities have been organized in science, technology, engineering, and mathematics. It is the objective of the mission of the US Embassy in Mauritius to deliver his address. Mr. Godot, the floor is yours.
Thank you, and good morning, everybody. Mr. Jagmohan Singh, Permanent Secretary of the Ministry of Tertiary Education. Mr. Shumro, the Chairperson of the Rajiv Gandhi Trust Fund. Dr. Aman Malu, Director of the Rajiv Gandhi Science Center. Directors of tertiary education institutions, members of the research and academic community, and partners people movement. So on behalf of the U.S. Freedom 250, Artemis, and U.S. Freedom, Innovation, and Exploration. I extend our sincere partnership in making this program possible. Today's event is part of the United States commemoration of the 250th anniversary of independence, a milestone that reflects 250 years of innovation, leadership, and exploration. That's why we're very happy to have Jim Adams, formerly of NASA, to be here to tell you all about it. So throughout our history, the United States has invested in science, Apollo missions, and the first moon landing to the space shuttle program, the International Space Station, and today's Artemis missions. Space exploration has expanded human knowledge and contributed to technological advancements that shape our daily lives. I remember as a child, sometimes I was able in Southern California to look up to the space and see when the space shuttle was coming back to Earth were some of the most inspiring parts of my childhood. Many technologies that we rely on today, satellite that mission, a travel standing friendship and cooperation between the United States and Mauritius, which dates back as far as 1794. And they represent how science and exploration connect nations and inspire future. Adams World, whose distinguished career in aerospace, innovation, and international collaboration continues to inspire audiences worldwide. We're very happy to have you here today and throughout the week. He's meeting the Prime Minister tomorrow. Since Monday, Mr. Adams' engagements under the Freedom 250 initiative have advanced dialogue on space innovation, research collaboration, and strategic partnerships in Mauritius. Through interactions with government stakeholders, academia, science organizations such as this one, educators like you, and students, the program has promoted awareness of space education, emerging technologies, and real-world applications of space science. Makers programs in Mauritius. Through the Center, American Center Port Louis and the American Makerspace right here at the Rajiv Gandhi Science Center, we provide young people and educators and communities with opportunities to engage with robotics, coding, artificial intelligence, digital skills, and hands-on STEM learning. And it's thanks to Audrey Ake, who is here in the audience, who oversees that program long-term for the embassy. Through our interactive program, States and a few international partners at the time to promote the peaceful, transparent, and respectful and responsible exploration of space. The Artemis Accords bring together have joined this initiative, reflecting a growing global commitment to peaceful space collaboration. We hope that Mauritius will soon join the growing community of Artemis Accords signatories as the 68th nation, or the 69th or 70th, but hopefully soon, to join the shared vision for peace. Innovations will also be highlighted at the U.S. engagement in science, technology, innovation. Thank you today for joining us, and I wish you a successful and inspiring program. Merci beaucoup.
against Adam's work technologies with more than 35 years of experience in aerospace industry. During his remarkable career at NASA, he contributed to over 30 spaceflight missions exploring Earth, the Sun, and much of our solar system. He also led investment across the Indian Sea. Today, Mr. Adam continues to support startups on safety while promoting much.
Wow, what an introduction. I want to meet that guy. I think before we get but that's not why I'm here today. It's a little bit bimodal. You'll see it shift in the middle. But it was 31 have been around the moon. Only 12 have walked on the moon, but only 31 people have been around the moon. That was more than I thought it was. When I totaled it all up, we came up with that number. 13 is in red because what you'll notice about them is they're all, except for Harrison Schmidt at the bottom there, They're all test pilots. They're all white dudes. And we're changing that. As we opened up, space station and then came back to it, in the 2020s, when we decided we were going to go back to the moon, we said it's no longer the domain of this demographic. It is the domain of all of humanity. And so we're moving forward with all of the skills that diversity brings to accomplishing huge challenges like going to the moon. Next. Okay, so. Obviously, because that's number 2. Artemis 1 actually went out and around the moon, and it carried dummies. No, next slide, please. Did not carry dummies. It carried 4 people. The pilot, Christina Cook, was a mission specialist, and Jeremy Hansen was. In here. um, and so you can see 3 people to the moon, and they were in pretty cramped quarters. It was like maybe going to the moon in a VW Polo, right? The Artemis crew went in a much bigger vehicle. Still, it was more like going to the moon in an SUV. But you had to get comfortable with all of that. Yeah, and that was the Artemis 2 mission. Let's see what's on the next slide. Okay. So you can't have a talk by NASA without a rocket. Students when I see this, when I show them this. One is that this, do you have a laser pointer or not? Yes? The space one? Inside all of is rocket fuel. And until we put rocket fuel inside of it, it's empty. The astronauts sit in this thing because the rocket fuel is we won't go over the details of this, but basically Space Center here, they looped around the Earth once, and then they looped around twice, and during that period of time, they were checking out the systems. All systems were go. Astronauts did there is probably not. So that's really what Artemis 2 and Artemis 3 are about. It's about testing the system before we go further to the moon. So that's my little aside about the Airbus 380. And just as another of the heat shield, but it all seemed to work out. The engineers had done their job well and figured it out, even though there were some people that doubted it. Next slide. Along the way, there was an opportunity to do some human science. So we had astronauts that were one of the things that you heard in my really glowing bio was that I was the deputy director of planetary science for one. So that actually I view as kind of the sweet spot in my career. I had the opportunity from Mercury to Pluto, including the rovers on Mars, Juno and Jupiter, Cassini at Saturn, Messenger at Mercury. We flew like comets, we landed on asteroids, we brought samples back. It was a really amazing time. So here's the really interesting thing about the Earth with the sun peeking out behind it. This is Artemis now. It's kind of like where you're at, right? Perspective is you're Artemis, the moon is here, the Earth is behind, and you are seeing the sun. Than the exposure time. You get more photons onto the CCD, and that enables you to see a little bit more. And that's exactly what the Artemis crew did when they were taking pictures. They increased the exposure time, and suddenly you could see more stars. City lights, you begin to see cloud cover, ocean currents. Scientists And it won't be for a 3-day um, of American leadership. This time it will be for all of humanity to go and to begin to put a foothold on the surface of the moon. There are things that we can do. Shallow regions are filled with water. Talked about rocket fuel earlier. What's rocket fuel made out of? Hydrogen and oxygen. What's water ice made out of? Hydrogen and oxygen. So we possibly could begin to fuel interplanetary rockets at the moon and avoid having to carry all of that hydrogen and oxygen with us from the surface of the Earth. We believe there's minerals on the as an aside, I wanted to say American leadership, we weren't called Americans at the time, but American leadership actually goes back 250 more years. So it actually goes back 500 years when the Europeans began to put a foothold on the North American continent. And during that period of time, they were choosing to do a hard thing for the day. They were choosing to go and live in a place is a mother invention. You land on North America, and all you've got with you is the ship and the pieces that were on the ship that you brought with you, but now you have to live off the land. Same with when we go to benefits to things that we never actually envisioned in the first place. And so lots of people have American people and people in the world actually have access to them. Next slide. All right, so why? What are some examples? Next. Stars, when we triangulate on another group of stars, and down here, and when we do it again. Yeah. And the folks at the Jet Propulsion Lab said, well, when we go out into deep space, we have to understand the objects that we're approaching. And so we use a radar. We use a very low power radar, but it's very high resolution. And so the two of them worked together, FEMA and Jet Propulsion Lab, and they came up with this thing called Finder. Finder is capable, it fits in a suitcase like you carry onto an airplane. It's capable of detecting a human heartbeat or respiration under 10 meters of rubble. And so in Nepal, when the earthquake, societal impacts of spin-offs, the economic impacts. By the way, I was asked if I yeah, mixed up. This could be upside down because I think this is Reunion Island here. But for the most part, this is Mauritius at night. Maybe some of you will recognize the lighting and be able to tell me if I've got the orientation correct. All right, next slide. That's not only good for keeping astronauts alive, it's good for keeping babies alive. And so for a while, up until the early 20s, happy with their own planes. So what the NASA tech transfer not a big landmass, but it is an enormous. He's emphasizing the continental United States. Which, by the way, if you've ever flown over that, it's also an enormous area. So I don't know. Or any other country can govern this. Some of it could be marine biology, some of it could be political partnerships, it could be societal change. For all I know, it could be social media, you know, but you're going to solve that problem, and that's going to create intellectual property that then Mauritius can spin back in to other problems. Here's a school student that's looking to solve the problem of human trafficking, or it's the young lady who wants to start up a business to apply AI to daycare, or whatever it turns out to be. They can utilize some of the solutions that you develop in solving this problem to solve their problem. And so what's important to me is massive spin-offs. They kind of fall into categories like this: public safety, transportation, information, all of that stuff. But the list is those. That mean that Mauritius will have an astronaut as soon as they sign the Artemis Accords? Of course not. You may not even have a payload. things, deliberations are being made. And that's important because just of the networking of one group helping out another group. And so Mauritius would show up with their own concerns about earth science and maritime awareness and begin looking for the spin-offs from the Artemis program that they can adopt into their own say, how many of you were alive in 2006? Well, let's try it here. Well, because NASA took your picture. This is Earth viewed from
Talk about the audience, right?
Okay.
Very much. And if you have question, please.
So I will tell you, I've answered questions. I don't do area one, and I don't do flat earth. Or you might be able to bait me into flat earth. Okay, go ahead.
Thank you very much for your time today and your wonderful presentation. My name is Madeline. I am associated with the U.S. Embassy as a Fulbright
just made me begin to think about the way the world works and the way gravity works and a desire. It was suggested that maybe I should switch to computer science because I was doing really well in computer science. But I didn't like it as much. I liked physics because it told me about the way the world works. And so I wish I could remember the fellow's name, but that's the guy. If you ask me who inspired me, it was my physics teacher in high school. Great.
Okay, so next question. Good morning to you and everybody. So I'm Stephen from Escape Secondary School and physics teacher. And I just have two questions. One is about how you guide a space shuttle, especially with the aerodynamics that you go behind and the dynamic of the air movement within our atmosphere. That's one question. And then the second question is, if we think about the gravity of the moon, which is one big slab of the Earth, so this means we probably need one fixed amount of fuel to use to escape the Earth gravitational field. So when you look at the pictures, we don't see that much of fuel being carried by the space shuttle, especially Apollo, for example. Yeah, so that's my question.
Okay, so thanks for teaching physics. Just like on the SLS and the rocket launch that I showed you, is almost all fuel because we needed to atmosphere in the in deep space. So if it's on its way back from the moon, the only thing you can do is push it this way or that way with little tiny rocket engines. And that's what we did, right? Now, how do you know where you're going? Well, we have gyroscopes on board, and we have inertial measurement units that tell us how much we're drifting or moving as a result of those little tiny thrusts. Right? Sometimes, like we did on the New Horizons, of Jupiter, and gain enough velocity that we shave 2 years off of the trip. A slingshot around another planet. So there's all kinds of ways that we guide. But in order to guide it, you need to know where it is. So one of the things that happened with Artemis, any communication stations around the world, including the ones in South Africa, and I would venture to say could have been also the communication station here in Mauritius, but I don't think it was. They started measuring the Doppler shift of the radio waves from the capsule as it appeared from behind the moon. Why did they do that? Because the more data that we had on the position of the spacecraft and its movement told us just
you. Good morning, everyone. As I already student sharing is sharing so much of it.
Thank you. Yeah, it's kind of a qualitative answer rather than a quantitative answer, but also science. Like they just want to know about the isotopes of oxygen in the Jovian atmosphere. But what we would tell the scientists at NASA, not science until you share it. And that's really true. There's no students that if they completed an experiment, then they go home and they tell their brothers and sisters about it, or their friends. I hope that as MRIC interns do research, or graduate students do research, a lot of us were convinced for resources coming and going between the moon. It becomes an economic ecosystem, right? An economic system. If we move from low Earth orbit out into the space around the moon and on the surface of the moon, all the while developing the missing technologies, the gaps that would enable us to go to Mars and come home safely. A couple of those gaps are, we don't know how to land a human on Mars. This is very different than landing on the moon. Another is, we don't know how to take off from Mars with anything. We've never done it before. On the moon, we did it during Apollo, but the Apollo systems are far too small to be able to bring a crew home from Mars. We don't know how they would eat. Would we once you leave the Earth's magnetic field, you're now exposed to radiation that no human has ever been exposed to before. So, and not to mention the whole dynamic of a crew of 4 people isolated in space, hurtling through the darkness and having no real are like all tiny solutions. There are people that are looking at how we might use it. I'll bet you by the time we're ready to go to Mars, we'll be looking at the next list. Where do we go after that? So, and that will be probably some of your students thinking. All right, was that the last question?
Yeah. And we now invite our and Dr.
How about outside? They kept asking me for input.
Ladies and gentlemen, we now move to the next segment of today's program, the launching of the exhibition. This exhibition commemorates the Freedom 250 program by showcasing major achievements in American space exploration. It traces gets seated in the first guests, please remain seated for one. Now, I think
secrets of the universe to change the world in air and space.
No, ma NPI mo, mo iban puso. No, ko ito, gusto ko man. Ano hindi, personal. Oh, Oh,